Welcome back to video lecture series Computer Architecture and Organization. In that we are going to see about the basic structure, basic processing unit, and the pipeline execution part one. Now let's see one by one. So in this, we are going to discuss about the introduction to computer architecture and organization. So first of all, what is in the computer picture and organization. So computer architecture, it is defined the design principles, instruction sets, and performance strategies that shape how a computer behaves like this. So while computer organization is nothing but focuses on the operational structures of the computer. So how components like ALU, control unit, memory, and I/O devices work together. Like, so what are the key concepts in the introductions? So in this, we are going to follow the architecture, von Neumann architecture, hardware architecture, instruction set architecture, risk versus risk, and a Flint's taxonomy. So here, the von Neumann architecture, so which is a single memory for instruction and the data sequential execution, where hardware architecture is nothing but separate memories for instructions and data enabling to process the data. So in this instruction set architecture is nothing but the ISA, which is defines the commands your CPU can execute of the programming. So risk versus risk is nothing but it's one of the architecture, designed architecture. So risk is nothing but a reduced architecture. Cisco, it is nothing but the complex instruction sets. It is used for the simplicity and the functionality. So next one is a Flint's taxonomy. Flint's taxonomy is nothing but the classification of your computer systems. It is SISD, SIMD, MISD, MIMD. So next one is why it matters, why we are studying about the computer architecture and administration. So based on the parameters like performance, reliability, and scalability and optimization. So these four characteristics, these four parameters very, very important to study about the computer architecture and organization. So first of all, we see about the basic structure. So basic structure in this includes functional units, instruction sequences, and addressing units, risk versus risk, and floating and the fixed point operations. So the core components of the basic structure. So ALU, control unit, memory unit, input output controllers. While ALU is nothing but the performance arithmetic operations, the control unit which controls all the instructions, fetching, decoding, and executes them using the timing and control signals. Memory unit which is store the whatever the program instructions are running in your computer, which is to access this memory and registers for immediate processing. So input output control is nothing but the communication between the CPU and the external devices like keyboards, display, printers, like next one is see. So one Neumann model in this fetch, decode, execute, store, and output. So these four steps you have to follow this accessory program. So the main component like ALU controllers, memory, and the IO controllers. So the next one is a basic processing unit. Basic processing unit, which is how we are going to fetch the instruction and execution. Next is the hardware or a microprogrammed control, register organization, and the timing signals. That is, so in this computer architecture, which is essentially is a brain of the computer. It's nothing but it fetches the instructions and decodes them and executes the operations and store the results. So these four terms are very, very important in the computer architecture and organizations. So in this, the basic processing unit, see, that is control unit, arithmetic logic unit, registers, timing and control signals, nano and the micro signals. Next one is the pipeline executions. Pipeline execution is nothing but so the computer architecture is a technique. It is a pipelining execution is a technique which allows a multiple instruction to be processed. It means simultaneously by dividing them into the sequential stages, like a line by line stages, which is going to improve the CPU throughput and efficiency. So first of all, what is meant by pipeline execution? So pipeline execution is a method of instruction level parallelism. Instead of completing one instruction before starting the next, the CPU overlaps the execution steps. So each steps of the pipeline executes a different part of the instruction, so multiple instructions are in process at once. Typical pipeline stages. So in this pipeline stages, there are instruction fetch, instruction before execution, and the memory access and write back. So these are the steps which we follow in the pipeline technique. That's all about the first part.